Okay, so this is where we were with secant is actually what we're graphing. Okay, I know this says y equals cosine because we graphed cosine with this dotted blue line. And now y equals secant. That does not look like a good equal sign. Y equals secant of x. As we said before, everywhere where cosine is 0, all these odd pi over 2's, that's where secant has the vertical asymptotes. Okay? And then we take these little parabolas here of cosine and we flip them because secant is the reciprocal of cosine. Okay? So the first parabola of cosine, kind of that we think of, does go from negative pi over 2 to pi over 2. The second one, the one that's opening down, goes from pi over 2 to 3 pi over 2. All right. So again, let's look at it on Desmos. Okay. We had already looked at cosecant last time. See, this is y equals cosecant. That's a little different. That one goes from 0 to pi, right? Because sine, if you think of sine is 0 at 0 and at pi. So that's where our vertical asymptotes are. Now it's going to be different because we're going to be doing y equals secant. And so as you can see, the vertical asymptotes are at pi over 2 and negative pi over 2. Okay? X equals pi over 2, x equals negative pi over 2. All those odd pi over 2's are where cosine is 0. So that's obviously where secant is undefined. Okay? So we have, starting at 0, 0, for secant, we start at 0, 1, and it's a parabola opening up between negative pi over 2 and pi over 2. And then from pi over 2 to 3 pi over 2, we have a parabola opening down at pi negative 1. Okay? The period is still 2 pi. We call this first part of the period starts at negative pi over 2 and goes to positive 3 pi over 2. That's a span of 2 pi. Okay? So if we look at what we want you to know about secant, the secant function f of x equals secant of x. The domain is all x's except the odd pi over 2's. Same domain as tangent, if you'll think about it. The range goes from negative pi or negative infinity to negative 1 and 1 to infinity, just like cosecant. Okay, since cosine goes from negative 1 to 1, right? It just stays between negative 1 and 1 the whole time. Secant, because we flip it, it'll go from 1 to infinity for the parabolas opening up, and from negative 1 to negative infinity for the parabolas opening down. All right, so this is what the secant function looks like on your graphing calculator. Notice that secant is the one that kind of straddles the y-axis, okay? The y-axis is like its axis of symmetry, whereas cosecant, the y-axis is actually a vertical asymptote. Okay. So the secant function, the graph, again, vertical asymptotes at all the odd pi over 2's. There aren't any x-intercepts, right? Think about it's from 1 to infinity and negative 1 to infinity. It's never crossing the x-axis. The period is 2 pi. There's no amplitude, okay? And this one is an even function. Secant is even, just like cosine is. Okay, now this is how we graph secant and cosecant functions. Okay, we graph its corresponding sine or cosine function with the dots, kind of like I just did, and then just flip it. Sketch the vertical asymptotes wherever the x-intercepts are of sine and cosine, and then let your asymptotes guide you for your parabolas. Okay, so you graph the corresponding reciprocal function. So if I'm graphing cosecant, I'm going to graph sine. If I'm graphing secant, I'm going to sketch cosine, okay? And then fill in where the asymptotes are, etc. Okay, you make these little U-shaped between the asymptotes. Okay, so let's try this one. Y equals 2 secant of 1/2 x. Okay, when I see that, y equals 2 secant of 1/2 x, then I know, well, let's see, the reciprocal of secant is cosine. So what I am going to do is graph y equals 2 cosine of 1/2 x. Okay, and I'm going to make it dotted. I'm not going to, because I know that's not actually the graph. I'm supposed to be graphing the secant, but I'm going to use y equals 2 cosine of 1/2 x as my guide. Okay, so if you recall how we did this, I'm going to let 1/2 x equal my key points. 1/2 x equals 0, pi over 2 pi, 3 pi over 2, and 2 pi. And see what my new x's are. 1/2 x, so I'm going to be multiplying all these by 2. 0 times 2 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. So those are all my x's. My y's for cosine are usually 1, 0, -1, 0, 1. Right? The cosine of 0 is 1. Cosine of pi over 2 is 0. I'm just doing my 5 key y's, but I am supposed to be multiplying. I'm going to be multiplying by 2. So I multiply all these by 2, and I get 2, 0, -2, 0, 2. So 0 gives me 2. Pi gives me 0. 2 pi gives me -2. 3 pi gives me 0. And 4 pi gives me 2. Try to get there, okay? And so I see the pattern. You know, I'm going every pi and toggling between 0 and 2 and -2. Okay, so this isn't my graph, by the way. I should be putting this in dotted lines, but I didn't, but I should have. Okay, and I missed the 2 a little bit. Okay, so now what I do is everywhere that I had a 0, I'm going to drop my asymptote, okay, because I'm doing secant, and secant is the reciprocal of cosine. So I have asymptotes at -3 pi, -pi, pi, and 3 pi. And then I'm going to make my parabolas either going up or down, depending on if I'm 1 or -1. Okay, right here would be a parabola if I could draw it. Okay, do you see it? So let's do it on Desmos so that you can see it a little better. Okay, it was y equals 2 secant of 1/2 x. Y equals 2 secant of 1/2 x. Y equals 2 secant. I'm going to put, oops, oh my, 2 secant of 0.5 x. There we go. Oh, why is that other x there? Okay. My asymptotes are mixed up. This is my old graph. Okay, so let's see. Yes, it looks like we were correct. Okay, look. I have my asymptotes at -pi and pi. See? Oh, sorry. And then from pi to 3 pi, I'm opening down. 3 pi to 5 pi, and at 4 pi I was at 1. Okay, you see it? Maybe I'll try to pull it in a little for you. Okay, my asymptotes were at -pi and pi. X equals -pi, x equals pi. x equals 3 pi. Okay, that's where my asymptotes were. My period, okay, a period is we need a u opening up and a u opening down. Okay, so my period went from negative pi to 3 pi. So I had a 4 pi period. Okay, that's what that 1/2 did. Instead of going through 0, 1, I was going through 0, 2, but that's not an amplitude. We don't talk about the amplitude. Amplitude is in sine and cosine only. All right, that's how you do that one. This one is cosecant. So I'm going to graph y equals 1/2 sine of x minus pi over 2. Okay, so again, I need my key points, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to let x minus pi over 2 equal that. So I'm adding pi over 2 to 0. Well, that would be pi over 2. I'm adding pi over 2 to pi over 2. That would be pi. I'm adding pi over 2 to pi. That would be 3 pi over 2. I'm adding pi over 2 to 3 pi over 2. That would be 2 pi. And this would be 5 pi over 2. I'm multiplying all these by 1/2. So it used to be 0, 1, 0, -1. Well, my amplitude is 1/2. So I'm going to graph those. What is it? Pi over 2, 0. And then pi 1/2. 3 pi over 2, 0. 2 pi -1/2. 5 pi over 2, 0. And it keeps toggling through those. Okay, the -1/2, etc. Okay, and so since I'm not really graphing, that's not my graph. I was supposed to do cosecant. Okay, so I am going to have asymptotes at the odd pi over 2's. And I'm going to have my actual graph will be these green parabolas. Green parabola down there, green parabola up here. Okay, I'm sorry, that's sloppy. Let's look at it on Desmos. 3/2 cosecant of x minus pi over 2. That shifted me pi over 2 to the right. You know, if I think about it. 3/2 cosecant of x minus pi over 2. 3/2 cosecant of x minus pi over 2. Sorry, I will get rid of all this stuff. Okay, and we said our asymptotes were going to be at negative pi over 2, pi over 2, 3 pi over 2, okay, etc. Okay, so usually I start my cosecant at 0, okay, but now I shifted it to the right by pi over 2. Notice instead of being up at 1, I'm up at 1/2. Here's my first u facing up or opening up. Here's my u opening down. Okay, I graphed sine, and then I just used where sine was 0 as my vertical asymptotes, and then I used where my 1 or whatever, 1 in this case 1/2 was, to flip my parabolas. I call them parabolas. They call them, they're really not parabolas. Okay, so that's what they're saying. To sketch the vertical asymptotes. Here it is nicely. These have the form of odd pi over 2's. Okay, and then after you sketch the asymptotes, you put in your u's. Look where the first u was. At pi, it went from pi over 2 to 3 pi over 2, and then a u facing downwards right here between 3 pi over 2 and 5 pi over 2. Okay.